From the granite chasms of Colorado to the cloud-covered peaks of China, the race for the world's highest bridge has reached a staggering new height. To understand where we are going, we first have to look at where it all began, the Royal Gorge Bridge in Colorado. For nearly a century, this was the pinnacle of American engineering ambition. 956 feet of steel and wood suspended over a granite chasm. Stand on its deck and you'll feel your stomach drop. The river below looks like a thread. Now meet its successor, the Huajiang Grand Canyon Bridge in China's Guizhou province. At 625 meters, it doesn't just break the American record, it shatters it. This bridge is so high that clouds drift between you and the canyon floor. Welcome to the new era of mega engineering, where bridges don't just span canyons, they redefine what's possible. Let's start with the legend. The Royal Gorge Bridge opened in June 1929. The Great Depression was months away, but America was building. The bridge took just 6 months to construct. 1,292 wooden planks laid across steel cables. It cost $350,000. Adjusted for inflation, that's about $6 million today. The men who built it were cowboys. No computer models, no stress analysis software, just slide rules, grit, and courage. They walked steel beams 956 feet above the Arkansas River with nothing but rope harnesses. Some didn't make it home. Today, it's a beloved tourist attraction, a bridge that became a theme park, zip lines, gondolas, and wooden planks that creak under your feet. It's charming, historic, American. But 95 years later, the Huajiang Bridge rewrites the rule book. Construction began in 2020. It took 4 years. The budget? Over $140 million US. But this isn't just a bridge, it's a statement. Every bolt was computer designed, every cable monitored by sensors, every piece of steel tested to withstand forces. The Royal Gorge engineers couldn't even measure. This is the divide. One bridge built by hand and hope, the other by algorithms and ambition. Let's talk scale. The Huajiang spans 2,890 meters. That's 1.8 miles. The main span alone stretches 1,420 meters. To put that in perspective, you could line up 4 Empire State Buildings end to end, and they'd fit comfortably. The deck sits 625 meters above the Beipan River. That's 2,051 feet. The Royal Gorge, 291 meters. The Huajiang is 2.15 times higher, but height is just the headline. The real story is in the engineering. Before we compare this to other mega bridges around the world, let's put the Huajiang in global context. France's Milo Viaduct is often called Europe's most spectacular bridge. It's taller than the Eiffel Tower. Its tallest pier stands 343 meters high. Impressive, right? But here's the thing. The Malaus roadway sits 270 meters above the Tarn River. The Huajiang's deck is 625 meters above the Beipan. That's more than twice as high. The Malau is a masterpiece of cable-stayed design, but it spans a gentle valley. The Huajiang spans a vertical canyon, where wind funnels upward like a rocket. Then there's China's own Duge Bridge, also known as the Beipanjiang Bridge. For years, it held the record at 565 meters. The Huajiang beat it by 60 meters. But more importantly, the Huajiang faces far more brutal wind conditions. Guizhou's canyons act like wind tunnels. They amplify gusts to terrifying speeds. This isn't just about building high, it's about building high in one of the most hostile construction environments on Earth. Before we dive into how they actually built this monster, quick favor, if you're fascinated by mega projects that push human limits, hit that subscribe button. We're Next Build, and we're documenting every record-breaking structure opening in 2026. Trust me, you don't want to miss what's coming. All right, let's get into the steel and stress. The Huajiang uses something the Royal Gorge builders never dreamed of, 2,000 megapascal high-strength steel. To give you context, standard construction steel maxes out around 400 megapascals. This material is 5 times stronger. Why does that matter? Because at 625 meters, every gust of wind becomes a weapon. Wind speeds at this height regularly hit 50 miles per hour. Gusts can exceed 80. You're not just fighting gravity, you're fighting the sky itself. Lead engineer Chen Wei described the challenge this way. At ground level, a 50-mile-per-hour wind is manageable. At 625 meters, that same wind can move a 215-ton steel section 3 meters in 5 seconds. We weren't just building a bridge. We were building a bridge inside a perpetual storm. Each steel truss section weighs 215 tons. That's heavier than a fully loaded 747 engine, and you have to position it with millimeter precision while it's swinging in hurricane-force winds, 2,000 feet above a canyon floor. The engineers called it threading a needle in a typhoon. Here's where it gets sci-fi. The Huajiang's cables aren't just steel. They're embedded with hundreds of fiber optic sensors. These sensors monitor tension, stress, temperature, and vibration in real time. Every second, data streams from the cables to a central control system. If a cable shows abnormal stress, engineers know before it becomes critical. If wind causes dangerous oscillation, the system alerts instantly. This isn't a bridge. It's a living organism. It senses, it reports, it protects itself. Structural lead Zhang Liang put it this way: traditional bridges are static. They endure forces. Our bridge adapts to forces. When wind hits critical thresholds, we receive alerts before human eyes could detect movement. It's like giving the bridge a nervous system. The deck was built using incremental launching. Here's how it works. You fabricate a section on solid ground. You push it forward using hydraulic jacks. Then you build the next section behind it. Push again. Section by section, like a steel caterpillar, the bridge grows across the void. But here's the catch. This is happening 625 meters in the air. One miscalculation, one misalignment, and 215 tons of steel plummets into the abyss. The workers wore full-body harnesses, safety lines at all times, but the psychological toll was immense. Imagine walking a steel beam, the width of a dining table. The beam sways, the wind screams, and the ground is 2,051 feet below. 4 years of construction, not a single fatality. That's a miracle of planning and precision. Now, let's talk about something nobody talks about: the environmental cost. The Beipan River Canyon is home to endangered species, rare birds, unique plant life that exists nowhere else on Earth. When you're drilling anchor points into canyon walls and dropping steel from cranes, ecosystems suffer. The Huajiang team implemented what they called zero contamination protocols. Every bolt, every rivet, every metal shaving was captured. Nets were suspended below work zones to catch debris. Drilling fluids were contained and recycled. When they had to blast rock for the tower foundations, they used precision charges that minimized shockwaves. Environmental officer Liu Feng described the challenge. We were building the world's highest bridge in a protected ecosystem. Every decision had 2 questions. Can we build it? And can the canyon survive us building it? The result? After 4 years of construction, water quality tests showed no measurable contamination. Bird nesting patterns remained stable. The canyon's ecosystem absorbed a megaproject without collapsing. Compare that to the Royal Gorge. Built in 6 months, multiple worker deaths. Dangerous, desperate, heroic. And built in an era when environmental impact wasn't even a consideration. Both bridges are marvels, but only one was built with the luxury of knowing exactly what could go wrong before it did. And only one was built with the responsibility of leaving nature intact. Now here's where the Huajiang does something radical. It doesn't just move traffic, it becomes the destination. The main tower rises 800 meters above sea level, but calling it a tower doesn't do it justice. It's a vertical city. And at the very top, there's a glass-walled cafe. It's called Interstellar Coffee. Building this cafe was arguably harder than building the bridge itself. Think about it. You're constructing a habitable structure at 800 meters. You need plumbing, electrical systems, HVAC, emergency exits, and it all has to withstand winds. That would rip a normal building apart. The tower's core is reinforced concrete, but the cafe structure uses aerospace-grade aluminum alloys, the same materials used in commercial aircraft fuselages. The glass is 60 millimeters thick, laminated, impact-resistant. It can withstand a direct strike from a 20-pound object, moving at 100 miles per hour. The elevator that takes you there is its own engineering miracle. It's a high-speed glass capsule, transparent on 3 sides. It travels 800 meters in 60 seconds. That's 13 meters per second, faster than most skyscraper elevators. But here's the challenge. Normal elevators run in enclosed shafts. This one runs on the exterior of the tower, fully exposed to wind. The engineers had to design a guidance system that could compensate for lateral wind forces in real time. The elevator car has active stabilizers, gyroscopes, wind sensors. If gusts exceed safe limits, the elevator pauses mid-ascent until conditions stabilize. You reach it via a high-speed glass elevator. The ride takes 60 seconds, 1 minute of watching the earth fall away, beneath transparent floors. When you step out, you're higher than the tallest building in San Francisco. You order a latte, you sit in a chair suspended in the clouds. Below you, weather systems drift through the canyon. This isn't just coffee, it's an existential reset, a reminder that humans can build seats in the sky and serve espresso there. But the cafe is just the warm-up. The bridge features a glass walkway, 1,900 feet above the canyon floor. That's 579 meters of transparent floor between you and oblivion. The glass is triple-layered tempered safety glass. Each layer is 15 millimeters thick, combined thickness of 45 millimeters. It can support 800 kilograms per square meter. You could park a car on it. Every step triggers primal panic. Your brain screams that you're falling. Your rational mind knows the glass can hold a truck. The war between instinct and logic is intoxicating. For the truly fearless, there's bungee jumping, a platform 300 meters above the river. That's 984 feet of free fall before the cord catches you. It's one of the world's highest commercial jumps. And at night, the bridge transforms into theater, a 300-meter-high water screen, lasers, projections, mist sculptures floating in the canyon. The bridge becomes a canvas. Engineering meets art at 2,000 feet. This is what China calls bridge tourism fusion. Why build infrastructure that just moves cars when you can build infrastructure that moves souls? The Royal Gorge tries. It has zip lines, a small amusement park, a gondola ride. But it was built as a crossing, not a destination. The tourism came later, retrofitted onto aging wood and steel. The Huajiang was designed from day one to be both passage and pilgrimage. Here's the uncomfortable truth. Of the world's 100 highest bridges, 99 are in China. 99. The only exception is in Papua New Guinea. Not one in the United States, not one in Europe, 99 in China. Meanwhile, America's infrastructure ranks 13th globally. Our bridges are aging, our roads crumble. The American Society of Civil Engineers gives U.S. infrastructure a C- grade. We have over 45,000 bridges, rated as structurally deficient. We invented the skyscraper. We built the Hoover Dam. We put humans on the moon. But in 2026, we're watching from the sidelines as others build the future. The Huajiang Grand Canyon Bridge isn't just a record, it's a mirror. It reflects what a nation can achieve when it decides infrastructure isn't an expense. It's an investment in what comes next. The Royal Gorge will always be an American treasure, a testament to what courage could build in 1929. But the Huajiang is a testament to what vision can build in 2024. One bridge looks back with pride, the other looks forward with ambition. So here's my question. Is the era of American infrastructure dominance over? Or can we reclaim our place as the builders of impossible things? Can we match the ambition that took us to the moon and apply it to the roads and bridges we cross every day? Drop your thoughts below. And if you want to see every mega project opening in 2026, subscribe to Next Build. We're tracking the future as it gets built. Thanks for watching. I'll see you in the next build.